Section 6.11, we're going to look at random variables. All right, so a random variable is the numerical values that describes the outcome of something, okay? We'll look at some examples because that's the easier way to understand it, but that's the technical definition, okay? They're usually denoted by capital italic letters, so X, Y, whatever. The letter doesn't matter, but it's written as a capital and in italics. There are two types of random variables that we're going to look at. A discrete random variable is a fixed set of possible values, and there are gaps between the values. So an example of this is if we define the random variable x as the number of heads obtained in 3 tosses of a fair coin. So if I toss a coin 3 times, the number of heads that I can get is 0, 1, 2, or 3. So that is a discrete random variable, okay, because there's a set number of numbers. There's only those 4 possibilities, and there's a gap between those possibilities. I can't get 1.5 heads, all right? So it has to be exactly 1, exactly 2, or exactly 3. In a continuous random variable, think of like a number line, it can be anywhere on that number line. So like if if you buy an 8-ounce steak at a restaurant, it might not weigh exactly 8 ounces. It could be 7.9, 7.91, 7.92, 7.989999, et cetera, et cetera, et cetera. Anything on that number line is what that steak can weigh. It's not limited to whole number values. All right, so the probability distribution, this is like exactly what we looked at last time with like probability models. So it has a list of the values, so all of the values that the random variable can be equal to, and then the probability of each of those values occurring. Okay, 2 requirements. This is not new. This is something we talked about last time. Every probability has to be between 0 and 1, and the sum of the probabilities has to equal 1. Okay, so if I want to find the probability of any certain event, I just add those probabilities together depending on what the event is. Okay, so let's look at an example. Here we have Pete's Jeep tours. And so these are the amounts of money that Pete can collect. Because his car is limited, he can only collect these amounts of money, and these are the probability that each of those amounts happens. So if I want the probability that Pete collects less than $600, that's got to be these 2 events here. All right, those are the only 2 that are less than 600, so I would add 0.15 plus 0.25. Okay, and that would give me 0.40. That's the probability that Pete collects less than $600 on a randomly selected trip. We can also take the probabilities of a random variable and make a histogram so that we can see those things that we talked about in chapter 1, shape, center, and variability. All right, so the variables or the values of the variable go on the x-axis, so all of the possibilities. So this is for the APGAR score, which is something they do for infants when they're born. So the possibilities are something between 1 and 10. All right, and then the probability is on the y-axis. So the probability of having an APGAR score of 8 is somewhere around 0.3. Okay. And then just notice that the bars are centered over each value, okay? It just kind of makes it clear that it's not between 1 and 2, it is actually the value 2. Okay. All right, and so just like before, we want to talk about shape, center. We can talk about whether it's skewed left, skewed right. We can talk about symmetric. We can talk about where the peaks are. All right, so this graph would be skewed left. If I were to kind of draw the curve, the long tail is on the left, so it is skewed left, and there's a single peak at 9. That's the one highest bar. All right, so back to Pete's Jeep tours. If I wanted to make a histogram of this, again, I would put the values of C, because that's what they're calling his random variable over here. So this would be like 300, 450, and I would list all of them, and then the probabilities would go on the y-axis, so it would have to go from 0 to the highest one is 0.35, and I could like put in random intervals in here, okay? So it should look something like this. All right, if I were to describe this shape, let me draw. That looks pretty close to symmetric, so we would say it's roughly symmetric with a single peak at 600. All right, so things that we need to be able to do with discrete random variables. We need to be able to find the mean, or it's also referred to as the expected value, okay? This is just a weighted average. Okay, so fancy little formula down here. Take each value and multiply it by its probability, add them all together. It's a weighted average, okay? So back to Pete's Jeep Tours, okay? If I want the expected value, I'm going to do each value, so 300 times the probability of 300 happening, which is 0.15. Plus 450 times the probability of that happening, which is 0.25. And then we continue this. Okay, so again, each value of the random variable times the probability of it happening, add them all together. And we got 562.50. So that's the average amount of money that Pete would get. When we're interpreting them, like everything else, there's kind of a sentence that we use. So if the random process of whatever we're talking about in the problem is repeated, the average number of whatever the random variable is equal to, we can expect is, and then whatever your expected value is. So for Pete, if the random process of selecting Jeep Tours is repeated for a large number of times, the average amount of money collected, because that's what C is equal to, we can expect is 562.50. All right, so here's one for you to try. So hopefully you got 8.128 as the expected value, and your sentence should look something like this. Doesn't have to match it word for word. Okay, in addition to the mean, we can also look at the standard deviation of a discrete random variable. Here is the formula. Just like standard deviation for quantitative variables before, it's a whole nasty mess that requires a lot of writing. So unlike my statistics professors in college, I am not going to make you do this by hand because it's silly with the technology that we have now. So grab your calculator. So just like we were doing standard deviation before, we need that stat menu. So on the Casio, it's going to be menu stat. And what you're going to do, and I've already done it here, is you're going to type in the values of X in list 1 and the probabilities in list 2. Okay, same thing if you're on a TI, it is stat edit, okay, and then type in the values of the random variable in list 1 and the probabilities in list 2. All right, so I've got the information for Pete's Jeep Tours typed in both calculators so we can see. So on the Casio, because that's what most of you have, we're going to do calc. All right, and we're going to do these one variable statistics, but we have to do something first. So over here, this is the settings. So you're going to press F6 for the settings. Over here where it says 1var frequency, instead of leaving that as 1, we're going to change that to a list, and we're going to make it list 2 because that's where we typed our probabilities. Okay, then exit to get out of that menu, and then it is 1var stats. And there is the standard deviation that we're looking for. Yours probably doesn't have that X. Yours probably says sigma, and then the X is little. Okay, on the TI, it is stat. We're going to go over to calc and hit 1var stats. List is list 1. Frequency list is L2. So if you see that, it's in blue above the number 2. So I'm going to hit second 2 to say L2 is my frequency list, and then calculate. All right, and again, there's our standard deviation, sigma x. So our standard deviation is here. The interpretation for it is just like it was in chapter 1 and 2. And so here's kind of your template. So the amount of money collected typically varies by 163.46 from the mean of 562.5. We calculated the mean earlier, but it is also in this one var stats, so it's x bar just like it was before. So 562.5 is also your mean. All right, so you try this one. And there is your correct answer. All right, so when we talk about continuous random variables, all right, that is where we have to look at the area under the density curve. Okay, so this is nothing new. We have already done this. So I'm going to show you really briefly two examples. So we could have a uniform distribution. All right, so take a second to read through this problem. But basically, this is exactly like what we've done before. If we want to know the probability that y is less than 4, I need to find the area under the rectangle or under the curve. Because it is a rectangle, it is just base times height. All right. That you can also, the normal distribution is an example of a continuous random variable. All right. And so this would be just like we did earlier. We can use our calculator, but you should draw a picture. And anytime you're using your calculator, you need to say what you typed in. You can't just give numbers. You have to say what those numbers mean. Okay, and so I can go over that some more in class if you need it, but it's review of things that we've done in previous units. So continuous random variables are just like the distributions that we did before, uniform and normal. All right, and that's it.